Thank you so much for joining our very first Data Observability Meetup. I'm Nisha and I'm on the marketing team here at Monte Carlo, and I'm accompanied by our speakers today, Itsai Blair, who is on the engineering team at Monte Carlo and former Barracuda and also Barracuda Networks and also father of one, and Bar Moses, our CEO and co-founder and former VP of Customer Success at Gainsight. And also, fun fact about Bar, she loves Bruce Willis. So if you have questions about Bruce Willis, you can ask Bar during Q&A. A couple of items on the agenda. If you're wondering what is our hour going to look like today, we'll talk a little bit about an overview of what is data observability. Then we'll go into the tech portion where we talk, a technical portion where we speak a little bit more about building a data observability platform. And then you'll have the opportunity to ask questions. So we'll have a Q&A portion. And then we'll also do networking. So we have, thanks to Zoom for having lovely breakout rooms. So we'll have breakout rooms and you'll have the opportunity to just network with other folks that are interested in this topic like yourself. And just a couple of housekeeping items. Please keep your mics muted just so that we don't hear any background noises while the speakers are presenting. If you have any questions, feel free to ask them anytime in the chat window. What I'll be doing is just taking a log of them, and then I'll ask them to the presenters at the very end. And of course, we all know that you want to rewatch this awesome presentation, so the session will be recorded and will be shared after the meetup. And with that, I will hand it over to Bar.
Awesome. Hi, everyone. So excited to speak with you all. Thank you so much for taking the time and joining us during this time. This is actually our very first meetup, and also my personal first Zoom meetup. I actually, for the first time ever, did a breakout Zoom just a few weeks ago and was like blown away by the experience for some reason. You feel like you're transported from different worlds. I don't know why, it sort of shook me a little bit. So I'm really looking forward to the networking portion, kind of to hear everyone's thoughts. And would love to sort of, to Nisha's point, would love to hear your thoughts along the way. So feel free to pop in questions, and if we can answer along the way or at the end, that would be great. So what you're seeing here in the slide is just a photo of sort of the Monte Carlo team. This is obviously taken pre-COVID days, which is why you see a big group huddling there. Back in the days when we could spend time in bowling alleys. So just a little bit about us. We come from all over the world, mostly from data or security backgrounds. Specifically in this photo, you see folks here from Brazil, Israel, Europe. I think there's New York and San Francisco there as well. And actually, in our last team event last month, we had an expert from Norway tell us about her research in black holes, actually, which was super cool. So that's our definition of fun. What we do sort of on a Monday morning with our global team. And we're all sort of on a mission to help companies accelerate the adoption of data by minimizing data downtime. And we're here to chat not at all about Monte Carlo. So hopefully this is the first and last slide about Monte Carlo, and we can jump into the main topic, which is data observability. I'll do a brief introduction of what data observability is, and then hand it over to Itsai, who will actually share probably the most interesting part here on like how to actually build some of what we did. So starting with what actually bad data is, maybe the one thing that's common to everyone here is if you had any experience with data whatsoever, you potentially experience a time where you encounter bad data. And what does that actually look like? Maybe for me in particular, this was like 5 minutes before a board meeting, the most important report that I had, I just learned that all the numbers changed and I can't use any of them and I don't even know why, and go figure what happened. Other sort of common stories if we hear from folks is, someone sort of makes a change to a schema somewhere or sort of changes something on your website, and that sort of has unintended consequences, where a marketing team works on a campaign and, everything sort of gets rejiggered and obviously sort of people can't use the data when you can't trust it. And so, I think we hear common horror stories like this all the time from small companies to large. Netflix, as an example, was down for 45 minutes back in 2016, I believe, because of duplicate data, actually. And so if there's one thing that's sort of common to anyone in the data industry is sort of the bad data problem. And we call it data downtime as a corollary to application downtime, actually. So if you think about sort of applications sort of being down, a couple of decades ago, if your website was down, honestly, nobody noticed because nobody was watching your website. But today, if your website is down, particularly for Netflix or any other company, it's a very big deal. And we think the same thing is happening to data. And so today, data can be wrong sometimes, some places, but we need to sort of treat data downtime with sort of the same diligence that we treat application downtime. One last thing here, data downtime, I mentioned sort of impacts any and all industries. In particular, it also impacts NASA. And there was a sort of a specific incident of data downtime in NASA. And I don't know if anyone in the audience knows it, but if you, the first two sort of either message Nisha or write in the chat with the answer for how data downtime impact NASA, will get a Monte Carlo hat or just get a hat. And so if anyone knows that, please feel free to write in the chat or message us. Cool. So data downtime as a problem is getting worse. There are a couple of things that are sort of happening in the industry, whether it's, people are sort of, folk kind of just using more and more data sources, which is pretty obvious. If there's one thing that's common to data teams is that, we always have more data to collect. There's no shortage of it. And we have increasingly complex data pipelines. So we're always changing data sources, shifting them in, shifting them out. And also, there's lots of decisions to make, right? Whether we choose a data lake or a data warehouse, or maybe a data lake house, or maybe both, or maybe a few of those, maybe a few BI solutions, different ML model options, et cetera. And so increasingly, we're all managing more complex architectures as well. And then finally, we now have so many different people working with data. We just named a few here: data engineering, data scientists, data analysts, product management, and even customer success. And the more people sort of working on data teams oftentimes means leading to just miscommunications and potentially sort of errors in data and more data downtime. So how do we actually deal with that? How do we actually manage that? Thinking about sort of the concept of data, or sort of where does data observability come from? Actually, again, sort of going to sort of the corollary for application downtime, one of the interesting things is when you think about data, I think there's this trend of thinking about data more and more like software and managing data like software, just something that we've been thinking about as an industry for the last couple of years. And if you actually think about the concept of observability in DevOps and engineering, that's a very well understood sort of concept and a very well understood framework. And so in the last couple of decades, there's this whole like frameworks and tools and solutions that have helped us think about managing observability on the engineering side and managing application uptime. And in the same way that applications can break for a million different reasons, so can data break for a million different reasons. And in the same way that we are meticulously managing the uptime of our applications, there's a need to also manage the uptime of our data. And so sort of define data observability as a corollary to DevOps observability, which is basically the organization's ability to understand the health of the data in the system, thereby eliminating data downtime. And so really data observability is sort of rooted in DevOps observability. But what does it actually mean, or what does it actually look in practice? And so, actually when we sort of set out to answer this question, we asked ourselves, okay, so applications can break for a million different reasons. However, there's this kind of coherent set of metrics that we track in DevOps that help us learn the health of the system. And then we pose the question of what is a corollary of that? Like what makes up data observability in particular? And after speaking with hundreds of data teams and actually like collecting a whole data set of information about data downtime and why data breaks, et cetera, we came up with these 5 pillars. And we believe that these 5 pillars holistically give you a view of the health of your data. So I'll briefly just walk through each of these. So the first is freshness. This is just an example of like one particular kind of way to think about freshness. There could be maybe potentially like a dozen ways to think about freshness in particular, but freshness is basically sort of the notion of, is my data up to date? What is its recency? When was it last updated? Are there sort of gaps in times when the data has not been updated? And do I need to know about that? So just as what you're seeing here is, sort of a view of a table that gets updated periodically, and then there's a large gap of time when it's not being updated. That's an example of what we'd call sort of data downtime or potential data downtime incident. The second pillar is around distribution, and distribution is really sort of everything about the field level health. And so just an example here is, believe this is around null values, if I can see well. Sorry, it's really small. Yes, null values. And so null values is an example of one metric that helps us understand distribution at the field level. So if for a particular field, you typically expect 0.6% null rate, and then suddenly that spikes up in a very significant way. That is a particular example of a potential data downtime incident. So you can think about probably several dozen metrics at the distribution level that sort of complete that. And then on the volume, this is pretty straightforward. So like literally whether there's like, more volume or less volume than you'd expect. This is an example of where you see less volume or sort of less rows. And then the fourth one here is schema. So oftentimes we find that schema changes are the culprits of data downtime incidents. And so, if fields are added, removed, changed, tables are removed or not loaded properly, et cetera. And so actually auditing or having a strong audit of your schema is a good way to think about the health of your data as part of this data observability framework. And then the last one is actually lineage. So lineage helps us put all four of these sort of pillars together in one, and helps us sort of paint the map of what this looks like. So in this particular example, it says table level lineage. You can also think about field level lineage, of course, or sort of at the job level. And lineage helps us tell a story. So we can say, here upstream, there was a schema change that resulted in a table downstream that had a freshness problem, that resulted in another table downstream that had a distribution problem, that resulted in a report that someone is using to make decisions or to drive digital products that's now corrupted in some way. And so these kind of like five pillars together are what we believe are sort of the constitute strong data observability framework. I breezed through this really quickly. So if any questions, feel free to put in the chat, but I hope this just gives you a little bit of a taste of sort of what data observability is. And with that in mind, I will hand over to Itsai, who will walk us through how we actually built a platform oriented around these concepts. They're not just marketing speak. There's actually technology and sort of product built around this. So with that, Itsai, all you.
Thanks, Bar. So before I dive into some of the engineering work that we went through in order to create the data observability platform, I want to share just a few examples of how we actually used our own product and how we experienced data downtime ourselves. So for example, if you look at the second example in the middle, that is a null rate anomaly that resulted in one of our engineers actually running some sort of cleanup job, removing some stale data from one of our production Postgres instances. And this resulted in this downstream issue in our data pipeline. So we use Snowflake as a data platform, and we have a data team that uses that. And this was a problem that we got an alert through Slack. These are all Slack alerts that we got from one of our engineers actually making a change in Postgres. And the third example at the bottom is also similar. This was actually me deprecating an old table in Postgres. Some of you, if you've had a chance to work, data teams versus engineering teams, you know that sometimes a change may happen on the engineering side. For example, here we dropped an entire table from Postgres, but this resulted in one of our ETLs failing. And it was obviously silently failing, as happens in many cases, resulting in stale data. So you can see that this table wasn't updated for 66 hours. So those are just some examples of how we kind of use our own product to figure out data downtime. And with that, I'll start diving into some more technical content about how we set out to build this platform. So one of the first things that we thought about, and I remember this because I joined very early on Bar and her co-founder Lior, and we were thinking about how we are going to build something like that. And one of we both Lior and myself come from security backgrounds, and security was top of mind, and we also knew how sensitive data is to all those potential customers. And so we knew pretty much from the start that we are going to need to take that into account. And so we came up with a hybrid approach where we have part of our system that runs on the customer's cloud account. And the other part, the data monitoring service, is something that we run on our Monte Carlo account. And this is opposed to having everything deployed on the customer's account and opposed to everything run within the Monte Carlo environment. So the piece that I'm going to be talking about more today is the data collector, which you can guess by its name is really responsible for collecting the data. This is the only component from a security standpoint, it's the only component that actually has access to the customer data, and the data never actually leaves that component. And that component, and I'll go into some more details in a sec, that component transmits only metadata back to the data monitoring service. So some of the key challenges that we listed out when we started building this was, as I mentioned, security first. So we want to have only the data collector component running on the customer's AWS account, being the only component actually accessing customer data, and giving full control over that component basically to the customer. So we have no control over that. The customer has full control, can remove that component altogether, can change permissions on that component. It's fully deployed on the customer's account. The second thing that we needed to consider was keeping the costs down. So obviously we don't want to have huge infrastructure that we spin up on the AWS account of our customers, and so we came up with a serverless approach, and I'll go into more details in a sec. We also wanted to keep that component easy to install. And not just easy to install, which is important because that gives a much better onboarding experience. We also wanted, and that's kind of the trade-off, that trade-off against security, right? We want to have this component run in a different environment, but we also want to be able to maintain that component, release hotfixes, optimizations, upgrade the component. And so being able to iterate quickly is really important to us, especially as a startup. And so we wanted to be able to do that as well. So that was another kind of key challenge that we wanted to tackle. And obviously, we also needed to be able to communicate back from that component over to Monte Carlo, to our data monitoring service. And so the solution that we ended up implementing is a serverless solution. So our data collector is essentially a group of lambdas that run in a serverless way and don't require spinning up resources ahead of time and paying for them up front. So you only pay for what you actually need to process. And to make deployment easy, we use CloudFormation to just spin that up. So it's essentially clicking one button on the AWS console, and it spins up this environment. So very, very easy to install. And in order to communicate back results, we use Kinesis data streams so that it scales very well, and we can consume those streams by multiple consumers if we need to. So it offers a lot of flexibility for us downstream. And to kind of keep that, I touched that point a bit, but it's super important for an engineering team to be able to iterate quickly over something like that. And once the collector is a remote component that runs in a different environment, it obviously complicates things. So one kind of very important thing that we decided to do was keep the data collector very lean. So it's responsible. It has a very kind of well-defined responsibility, which is to collect data. So it collects data, for example, from the data warehouse, such as Snowflake, or it collects data from some BI tool like Tableau, and it doesn't need to concern itself with much else other than that. And in order to be able to upgrade and maintain this component, when we spin up this CloudFormation stack and having the code basically run on a Lambda means that we can push code changes in a seamless way without having to concern our customers. Obviously, if we need to completely change infrastructure, that requires permissions that we wouldn't have. But if we need to fix a bug or perform some sort of optimization, we can release that in a seamless way without having to bother our customers. And yeah, that is kind of the high level of how we set out to build the data collector. And just to recap some of these best practices that I think would be useful for other engineering teams trying to tackle similar problems, is investing early on in security, not leaving it for a second or third iteration, because those are the type of things that are very, very difficult to come back to and change. And this was a very kind of important architecture decision in our kind of in this project. And second, so you want to, the second part of this trade-off is to still kind of leave room for how you're going to maintain this component and upgrade it and add new integrations to it. So you have to kind of make sure that when you're creating this, you also keep the door open to upgrading it. If it's a super difficult, it's a huge project for the customer to upgrade, then the customer is just not going to do that, and you're going to be stuck with very, very old versions of the data collector. And then last is separating those engineering concerns. So having a collector that is only responsible for a very specific job, which is collecting the data. And then this means that we have a lot of business logic that does not need to sit in the data collector itself, and can and we can iterate over it even more quickly as it resides in our application side. And that's kind of another key takeaway that I think is worth mentioning. And also want to kind of thank you for taking the time to listen to this talk.
Super, and thank you for sharing all those best practices and all of your awesome knowledge, Itsai. I guess just before we hop into the Q&A, if you are riveted by this topic and want to learn more, please feel free to check out our blog at montecarlodata.com/blog and ask us any questions at info@montecarlodata.com. And also, if you have any other ideas on topics for the next meetup, we'd love to hear them as well. All right, so if you have any questions, looks like we have one here from Bill. Thanks for making such a cool product for MC. Are there prescribed analytics pipeline configurations, e.g. naming conventions, certain types of transformations, extract versus live connections that make the monitoring more performant and proficient? I don't, Bar, did you want?
Itsai, do you want to take that? Itsai, did I lose you? The question.
No, I'm here. I'm trying to decipher the question.
Well, Bill is on the line, so we can actually ask him. Luckily,
that's a good point.
Bill, can we ask you to clarify? Can you say a little bit more about your question? Hi, Bill.
Yeah, sure. Hey, everybody. I guess the headline, this is a cool product and cool idea, so awesome work, really cool. But the question is, are there prescribed configurations in the stack that you apply Monte Carlo to that make the product more performant or actually more proficient? Are there certain limitations, I guess, in Monte Carlo that like where you would prescribe to shy away from like, heavy transformations in the Tableau layer or the BI layer versus like in Snowflake versus like in dbt or whatever?
Yeah, great question. Itsai, I can take a shot at this and let me know if you have additional thoughts. So I think, the way that we've designed this product, and by the way, curious also, I think in the networking portion, we'll talk a little bit about what other solutions folks have built. So really curious, honestly, just to hear, because I know folks, oftentimes we hear folks have spent time thinking about at least one portion or another of this. So really curious to hear kind of how how folks are thinking about this. The way that we've been thinking about this is there's a couple of sort of principles that help them make these decisions related to your question. One is the solution has to work with your existing stack. So it can't actually require you to change, anything or sort of write within a particular sort of language, whatever it is, like it has to work with your existing stack. And so we've invested a lot in building sort of our collector that Itsai talked about and the integrations that we have to work with your stack as is, actually. So just as an example, we might connect to Tableau, like you mentioned, or Looker, or Snowflake, or Redshift, or BigQuery, or any data lake that you might have. And so from that perspective, we sort of work, I don't want to call it out of the box, but we have integrations that make it very easy for any stack. Again, with the goal of like making it very easy for folks to use, because we know that like it's very common for someone to have multiple data warehouses, multiple BI solutions, et cetera. So, we definitely see a good array of configurations that folks have, including sort of a number of different solutions that you mentioned. And we think that part of building a strong data observability solution means the ability to have the ability to work with any configuration that you might have. And so we've invested a lot in building this in a way that can be standardized across different solutions, if that makes sense. Did that answer your question? Yeah. Okay.
Yeah, it does.
It's a real thumbs up, not a emoji thumbs up. So yeah. Cool.
Yeah, and maybe if folks also want to unmute and ask their questions, since there's not very many of us on the call, I think we can easily do that. But it looks like Jay has a question below here. If a company uses multiple accounts in AWS, how can you merge the collected metadata?
Good question. So I think I can take that. The nice thing about this, the data collector component, is that it doesn't. It's by design meant to give you full control over the component that actually touches the data, but it can really run within any AWS account. So we also offer hosting it ourselves if that's more convenient and if that's not a concern for you. And so it's the only thing that this component really needs to be able to do is have network and permission connectivity to the data sources. So for example, if you're using Snowflake as a data warehouse, the data collector would need to be able to access your Snowflake instance. And so we can collect data from multiple sources. We can collect data from Snowflake or another warehouse type and BI sources, and consolidate all of this on our end. And so there is really no requirement to run more than one instance of the data collector. Let me know if this was not the question, though. I'm happy to elaborate.
So I guess my question more for them. So if multiple departments basically have their own accounts, their own VPCs, right? So they have their, the databases for their applications, and then through, say, CDC, it's being pulled into Parquet files and then piped over into a BI VPC, where it is then cleansed, munged, dumped into a data lake, cleansed some more, and then ends up in Redshift or some other BI database. So that's a whole lot of lineage happening there, and probably more data sources enriching it along the way. And so basically, data may be hopping cross account, multiple VPCs coming together. So basically, that's a whole lot of different areas to account for, and then bringing that insight of where all that data is coming from, because it may be hot and ready in one environment, but something broke in a transfer, so now it's stale over in the BI environment. So you have, one side still hot, one 24 hours behind. So how can you see that refresh didn't happen correctly?
Yeah, great question. We have this magic solution that just like sees everything. No, I'm kidding. Almost. No, I mean, yeah, it's a great question. I think our approach has been, first of all, our solution is API based, just to get started. So, we basically, very specifically have like, we need read-only access to, let's say, like, I don't know, S3, Hive, Redshift, Tableau, just as an example. And then what we do is we actually recreate or sort of reconstruct the lineage across those solutions. So we can say we actually reconstruct the dependencies within, say, Redshift or Snowflake for that matter, and also make that connection to the BI solution as well. So we can tell you, and to the data lake too. So we can tell you there's a table here, and here's all kind of the tables that depend on it, and here are the reports that that are being fed by these tables. And so I can tell you this table upstream has a particular freshness problem, and this table downstream that depends on it is now impacted by that problem. And so what we do is basically we collect, or sort of the data collector looks at metadata, query logs, and sort of aggregated statistics, and sort of infers the connections based on that information. Does that answer your question?
Yeah, I think so. Thanks.
Did you ever see a meetup end on time? I feel like that's the achievement of the moment right now.
It's like one of the top 3 reasons why people go back to meetups is when you have a clear agenda and people know they're going to be out on time, then they will always show up. It's true.
Do we have everyone, Nisha?
Yeah, I think so.
Awesome. Cool. Yeah. Well, I guess with just 1 minute left, just wanted to say thank you so much for spending time with us. We are obsessed about all things data, and just thrilled to connect with kind of folks who are get excited about this. So if you'd like to stay in touch with us, there's some links here. There's my email there. Please don't sign me up for any spam lists. I tend to get more and more of these days, but if you'd like to reach out, I would just love to connect and continue the conversation. We love thinking about sort of a variety of topics from data downtime, but also data mesh, data lake houses, what's new. And we also love hosting these sort of meetups. So if there are other topics that you would be interested in sort of having a meetup like this, or even if you'd be interested in sort of co-hosting a meetup with us, or even sort of giving a talk about something that you're really passionate about, would love to hear from you all. So please don't be shy to and reach out. And if there's no other questions or anything like that, I'll just end up with saying a big thank you. And it was so awesome to spend the last hour with you all.